right, so now we're looking at further math topic 4.4. We're going to talk about binary operations. So let's start by defining the binary operation. So we use the star or the circle generally when we denote binary operations. And binary, so I know that you guys from your computer science knowledge know that binary is involving two elements of the set. There's also unary operations and ternary, which would have 3 elements. But in this course, this is another one of your, if you want to know more, wait until college sort of things. In this course, we're only going to talk about binary operations. So a binary operation is a well-defined rule for combining 2 elements of the set. Okay, so well-defined rule combining 2 elements. So examples of this are addition, subtraction, multiplication. Let's use the correct symbol here, multiplication, division. All of those are binary sets. If the result, and all the results, not just a single result, if all the results are elements of the original set, we call that closed. So closed has all the results are elements of the original set. To be binary, the result doesn't have to give us an element of the set. Yeah, we could end up with elements that are not in the set. Coming back to the star or the blob, we will sometimes have operations that are not these or that are different. And especially because this topic is general sets, operations, groups, sets, relations, groups, we've got these general symbols. The reason that they call this blob is so that it's not confused with composition of functions. I hate that we use the word blob, though. I think it's silly. So, all right, those are binary operations, and that's the definition of closed. So let's look at an example of this. So which of these sets are closed under the given operation? So integers under multiplication, well, if we multiply any 2 integers by each other, we will get another integer. So this is closed, because integer times integer always results in another integer. All right. All the real numbers under division, well, we know that any number divided by 0 is not an element of real numbers. So this is not closed. All right. Rational numbers excluding 0 under division. So any rational number, so let's let a and b be an element of rationals. So a divided by b, that's always going to give us another rational. Boy, that's a terrible rational symbol. That's a little bit better. So this is closed because b is not equal to 0. All right, rationals under explanation, it's a terrible word. So if I take a number and raise it to a fractional exponent, then I'm not going to get a rational number. So let's take, for example, 1/4 raised to the 1/2 power. Oh, that's a terrible example because that is actually going to be irrational. Let's raise it to the 3rd power. That's going to give us 1 over the cube root of 4, which is not a rational number. So this is not closed. Okay. Integers under subtraction. Integer minus integer is going to be another integer. So this is closed. And now -1, 0, 1 under multiplication. I'm going to use this time to show you a Cayley table. So operation tables, also known as Cayley tables. I'm going to make that up here. So let's put F up here. So my table is showing the operation of multiplication. I've got the elements -1, 0, 1, and I'm going to list those on both sides. And now I just perform this operation. So -1 times -1, 1, 0, -1, 0, 0, 0, -1, 0, 1. And now I can see that all of these elements are part of my original set, so this operation is closed. And that's our first example.